Welcome to Math Made Easy. This lesson is on adding and subtracting rational expressions. So remember, when adding and subtracting fractions, you must have a common denominator. And just as a quick review, rational expressions are expressions where you have a numerator and denominator that are both polynomials. All right, so let's look at some examples. So 4 over 3y plus 7 over 3y, those already have a common denominator. So we're just going to simply add the numerators and keep the denominator the same. So let's see what that will look like. So remember, when you're adding or subtracting fractions, common denominator, then you add or subtract the numerators and keep the denominator the same. 11 and 3 don't have any common factors besides 1, so that would be your answer. All right, here's another one. They already have a common denominator. So I'm going to add 3x plus x and keep the denominator the same. 3x plus x can be simplified to 4x. And that will be your answer. All right, let's look at one more that already has a common denominator, and then we'll go and look at ones that don't already have a common denominator. So add or subtract the numerators. Now be careful. This is not minus 4x. This is minus 4x plus 3. So let me show you what I mean by that if you're not following what I'm saying. Minus 4x plus 3. And so what that means, let me go ahead and write the denominator in here. So 3x squared minus x minus 2. What that means is that you're going to want to distribute that minus sign inside of here. So you're not just subtracting the 4x, you're subtracting the 4x and the 3. And the denominator here can be simplified by factoring. So let's deal with the top first, the numerator. So I'm going to rewrite this as 7x plus 5 minus 4x minus 3. So I just distributed the minus sign to both the 4x and the 3. In the denominator, this is a trinomial. The coefficient on a squared is, sorry, just lost my thought for just a second, is not 1. So the technique I teach my students is slip and slide. And so we're going to take that 3x squared minus x minus 2. We're going to multiply the 3 times the 2. That's going to give us x squared minus x minus 6. Now I'm looking for two numbers that multiply to negative 6 and add to negative 1. So it'd be negative 3 and positive 2. So this factors to x minus 3 times x plus 2. Now with this technique of slip and slide, you have to bring this coefficient back down here and divide. So this simplifies to 1, so that would be x minus 1. Can't simplify this, so the denominator of the fraction comes up next to the variable. You'd have 3x plus 2. So that's the factored form of 3x squared minus x minus 2. So let's go ahead and put that in our denominator. So you always want to factor when you're simplifying so that you can see if you can simplify things further. So in the numerator, let's combine like terms here. So 7x minus 4x would be 3x. 5 minus 3 is 2. So 3x plus 2 over x plus 1 times 3x plus 2. The 3x plus 2 over the 3x plus 2, they cancel out. And so your final answer is 1 over x plus 1. So if you haven't learned how to simplify rational expressions, you should probably look at that first. And I just noticed that, okay, so this is rational expressions. My file, I named it as radical expressions. It's not radical expressions, it's rational. All right, so let's look at some other examples here. Okay, so these have a common denominator still, so we don't have to do as much work here. So again, this minus sign, let me just write it out so that you follow what I'm doing. 7q minus 3 minus 6q minus 5. So I'm going to have to distribute that minus sign into here. And that's going to all be over q squared minus 4. So when I distribute that in there, I end up with 7q minus 3 minus 6q plus 5. So this minus coming in with that minus makes a plus 5. And this is all over q squared minus 4. Okay, so in the numerator, let's combine like terms. So 7q minus 6q is q. Negative 3 plus 5 is positive 2. And in the bottom, in the denominator, this is one of the hardest ones for my students to remember. This is a difference of squares. Q squared and 4 are perfect squares, and they're being subtracted. So that can be factored into the square root of q squared is q, and the square root of 4 is 2. And one of these is plus, and one of them is minus. So that's a special case that you would just have to memorize that to know that that will factor into that. And now I have a q plus 2 over a q plus 2. Those will cancel out. And so my final answer is 1 over q minus 2. All right, so what if you don't have a common denominator? So we need to get a common denominator here. So the least common multiple of 6 and 2 would be 6. So I can change this one to a 6 by multiplying the top and the bottom by 3. So let's see that. So I multiply the numerator and denominator by 3. That gets me to 6x squared here. Okay, well, then I need to multiply this one by x to make it 6x squared. So multiplying this one by x will give me 6x squared. Multiplying this one by 3 will give me 6x squared. And then I'll have a common denominator. Make sure whenever you multiply a fraction, you multiply the numerator and the denominator by the same thing. So now I have 5x over 6x squared plus 9 over 6x squared. And now we just add the numerators, 5x plus 9. Denominator stays the same, 6x squared. And that's it. We can't simplify that anymore. All right. So let's look at this one. So 7 and 3, the least common multiple of those would be 21. So I need to multiply this one by 3 and this one by 7. And that gets us to 21y squared and 21y to the 4th. So to make this one y to the 4th, we need to multiply it by y squared. So we'll multiply the top and the bottom by 7y squared. So that gets us to 9 over 21y to the 4th plus 14y squared over 21y to the 4th. Go ahead and add the numerators. So 9 plus 14y squared over 21y to the 4th. And there you go. All right, I think I have one more slide for you. Okay, what if the denominators are binomials? How the heck do I get a common denominator out of this? Well, what you're going to do is you're just going to multiply each of the binomials by the other binomial. What do I mean by that? Well, change colors here real quick. This one, I'm going to multiply by d plus 2. D plus 2. I should have given myself more room. And this one I'm going to multiply by d plus 1. And whatever I do to the denominator, I got to do to the numerator also. So d plus 2 times 3 and d plus 1 times 2. So in the denominator, I have d plus 2 times d minus 1 and d plus 2 times d minus 1 This should have been a minus 1. I'm glad I just caught that. But they're not the same right now, right? Oh, let's just erase all that. So luckily I said that out loud and caught my mistake. So I multiplied this by d plus 1 the first time. It should have been times d minus 1. And so what I did is I took this binomial and multiplied it times this one. And I took this binomial and multiplied it times this one. And now our denominators are the same. So what we have, let me expand this out a little bit. We have 3 times d plus 2 minus 2 times d minus 1 over d plus 2 times d minus 1. And you don't need to multiply these together. So leave it like that. But let's go ahead and simplify the top. So 3 times d is 3d. I'm just doing the distributive property. 3 times 2 is 6. Minus 2 times d is 2d. And then this minus coming in with that minus is going to make plus 2. And again, that's all over d plus 2 times d minus 1. Combine like terms up in the numerator. 3d minus 2d is 1d. I don't need to write the 1. And 6 plus 2 is 8. And I don't know why I wrote a 6. I was thinking about something else. That, make it blue. Blue. Okay. So 6 plus 2 is 8 over d plus 2 times d minus 1. And there you go. Can't simplify that any further. So let's look at one more of these. Well, let's change colors just for the heck of it. Go with purple. So I'm going to multiply this one by c minus 2. And I'm going to multiply this one by 3c minus 1. I don't have any idea why I just wrote an I. That is the strangest thing. It's late in the day and I'm tired, if you can't tell. No excuse, but it's the truth. So 3c minus 1. Got to multiply the numerators by the same thing. So c minus 2. All right, so in the top I have c times c minus 2 minus 4 times 3c minus 1. And this is all over c minus 2 times 3c minus 1. Go ahead and distribute here. So that gives me c squared minus 2c minus 12c plus 4. And that's all over c minus 2 times 3c minus 1. And now I'm going to start working down. Combine like terms up in the numerator. That gives me c squared minus 14c plus 4 all over c minus 2 times 3c minus 1. And you can't easily factor the numerator. You could use the quadratic formula, but we're not going to go that far because there's not two numbers that multiply to 4 and add to negative 14. So we're going to leave our answer just like that. All right. So that's adding and subtracting rational expressions. I hope that was useful to you. If so, give it a like and a subscribe. And feel free to leave me a comment. Until next time.